Hello everyone, welcome to my channel. So today we are going to do blind 75 questions, another question valid palindrome. So let us first read this question, then we'll check about the constraint, then how we can implement this question, and what would be the time complexity and the space complexity for the same. So let us first read this question. So here a phrase is a palindrome. A phrase is a palindrome if after converting all uppercase letter into lowercase letters and removing all non-alphanumeric character, it reads the same forward and backward. Alphanumeric character include letters and numbers. Given a string is, return true if it is a palindrome or false otherwise. So basically we are given with a sentence which is there, means a string is there which has spaces as well, which has numbers as well, which has lowercase characters and some extra characters as well. So now we need to check that is that particular string which is given to us, it is a palindrome or not. So here if it would have been a simple palindrome, means just a string which don't have any numbers or spaces or any other extra characters other than the alphabets, then it would be a pretty much simple question, right? Means a straightforward question, just we need to check that whatever it at the starting, it should be at the ending as well, and like that manner using a 2-pointer we could have easily solved that particular question. But now here the question is that we need to check that if there is any space, if there is any other extra character apart from the alphabets, so all those things we need to check and accordingly we need to implement. So just think about the fact that how you will do that, and accordingly you can code that. Now here if we see the constraints which are there, that are up to 10 raised to power 5. That means if we go ahead with n square solution, right, so that will be up to 10 raised to power 10 and that will give us TLE. So we need to implement the solution in order of n or order of n log n, and S consists of all the printable SKI characters. Apart from SKI character it won't consist of any other character, that is this case here. So now here the thing is, like if we take this particular example, this a man, a plan, a canal and Panama, right? So here the thing is that we need to check only this: a man, a plan, a canal and then Panama. We just need to check this particular string. We need to omit all the commas which are there, all the spaces which are there, all the colon which are there. That all we need to check. And even we need to check if it is in uppercase, we need to convert them in lowercase. So all these things we need to check. Means first thing would be only check for alphabets which are there. Means only check for alphabets. Second thing would be make all either lowercase or uppercase, but it should be the case that everything should be like that. And then simply it will burn down to the question of checking the palindrome. That would be the thing, and that is what this question asks us to do. So like this we will be implementing our question. So now here after doing all this, we need to check that what would be the time complexity and space complexity, if we will be using any extra space or not. That would be the whole scenario. But the way we can implement this question is without using any extra space, and even the time complexity would be also order of n, as sorting is not required here because we need to check the palindrome, right? So the string should be as it is. Only thing is we just need to check alphabets which are there. So now let us implement this question, that how we can implement this. I have given you these key pointers. You can check out and code by yourself that how you can implement this, right? Else I'll now just code this question. So now if we want to code this, how we can code this is, so here, so the first thing would be, here we need to check for only alphabets, convert all to lower cases or upper cases, and the other thing is we just need to compare alphabets. And the fourth thing which is there is we need to check for any space which is there or a single character which is there, because that would be the edge case here. So the first edge case which is there is that if at this s which is there, if s dot length which is there, it is less than or equals to 1. That means if it is a single character or a space is only there, then in that case we will return true, because that is anyhow a palindrome, right? Now the next thing, we need to have a starting pointer and we need to have a ending pointer. Basically we will be checking the way we use two pointer approach when we check usual palindrome, right? So starting pointer and ending pointer, this would be the thing which we will be going ahead. Now the next thing, as per the two pointer approach, while our start is basically less than end, till then only we will be moving ahead. Now comes the part we need to omit all the spaces, characters other than alphabets. So for that case what we need to do? So for that case what we will be doing is, we will check that start is still less than our end, right? And we need to check that if this particular is alphabet or not. So for that, in C++ we have is alpha function, so that we will be checking. So if it is not an alphabet, so we will just increase the start pointer. That is what we are going to do. And same goes with the end pointer as well. Same thing we will be doing for the end pointer. Only thing would be that we will be decreasing the end pointer, because we are going ahead from the last, and this we will be checking for the end. So by doing this, we will be reaching at a common point that both of these are alphabets. Not a common point, is basically a common character, that both of these are alphabet. Now we need to check that if our start which is there, it is less than end, means we always need to keep a check on this, because of the fact that there could be possibility that it has exceeded at any particular point. So that's why we need to keep a check on that, and then we will be doing two lower for both of the cases, for that starting character as well, start, and for the other character which is there, means that is the end part which is there. So here we will be doing two lower for that particular end also. We will check if both of them are not equal, that means they are anyhow some different character, and that means it is not a palindrome. So we will return false at that case. And then now we have checked for that particular character if it is palindrome or not palindrome. If it won't have been a palindrome, means equal character at this point, anyhow it will return false. If it was, then surely it won't enter that if condition, right? So we will just do start plus plus and do end minus minus. That means we have checked the character which was contributing to be a palindrome. Now anyhow all these things we have checked, that we are checking only the characters. That's why we are having this particular condition, these two conditions which are there. And here we are checking that if they are not equal, then in that context we are just returning, and we are always keeping a check that these two pointers are always in limit. That means start is always less than end, and then we will at the end return true. That means that it hasn't exited at this particular point, right? Or it hasn't exited at this particular point. That's why at the end we have passed all the cases, and that's why we will be returning true. Now the thing here is that what I was about to say, yeah, basically all these things are done, right? I forgot I was about to say something, but fine. Now comes the part about the time complexity and the space complexity. So now the time complexity which is there, here it is order of n, and these are also contributing to order of n only, but these are in pace with this, because see, anyhow we are utilizing the start which is being here, that is being incremented here, and that is being decremented here, means the end which is there, right? So anyhow those are same characters only which are being, those are same pointers only which are incremented and decremented, right? And here the check is also on the same, and here increment decrement is also for the same variables only, right? So that's why anyhow this whole becomes order of n rather than becoming order of n square, because it could be possibility that this is while loop, nested while loops, that's why it would be order of n square, but that is not the case, because what we are doing is, this is the same variable which we are using here also, and when it is being incremented, right, so that is only checked here also, and again it is incremented. So the same is being used here also. That is the case. So that's why it's overall becomes order of n solution only. And space complexity, anyhow we are not using any extra space, so that's why the space complexity is order of 1. So here the time complexity is order of n, and n here represent the size of the string, and space complexity is order of 1, which simply represents that we are not using any extra space. So this was all for this particular question. If you have any doubt, you could comment that down, or if you have anything in mind that this could have been done by this method or something like that, that also you can comment. I will solve that doubt as well. And yeah, if you really like this video, you can like, subscribe and share this video among your friends. So this was all. Thank you.